Welcome student, welcome to our YouTube channel Chemistry Table. Today we have the part 6 of the chapter 2 chemical bonding. This part is important or not, it is meaningless because if you are preparing for ICSE class 10, then each and every lecture from each chapter is important for you. So watch each and every part. You can check our playlist. In playlist we have chapter wise, part wise video. Each part contain so many concept that is important for our board ICSE class 10. So prepare your own note from this video and prepare the question answer that is given in our WhatsApp channel. Then you are ready for your board examination. So let's get started. Our next part, formation of covalent bond. In the previous part 5, I already discussed the two examples of the formation of covalent compounds. First was hydrogen and second was, I think, chlorine. So today I will discuss the third example, and most important example for your board is nitrogen. Okay, the end of the part of these 6, after completion of the discussion of part 6, at the end of this video I'll give a common question for your board examination ICSE. If you know the answer, so then comment your answer in comment box. After the discussion of the all concept, at the last I'll give this question. So now look at the board. Nitrogen. What is the electronic configuration of nitrogen? Atomic number of nitrogen is 7, so 2, 5. How many nitrogens are here? 2, so 2, 5. Okay, now tell me. 2 nitrogen, they have the tendency to accept 3 electrons because after accepting the 3 electron, they have fill up octet. That is valence shell, and it is also. Since both the atom have the tendency to accept the electron, as I told in the part 5 as well as part 4 video, if the both the atom has the tendency to accept this electron, then both the atom form a common space. They will try to accept 3 electron. Instead of accepting, it will donate 3 electron here. Suppose this black one donated by the first nitrogen and this blue one donated by the second nitrogen. So tell me, it donates how many electrons? 3. So in the valence shell, how many electrons are left? 2. Look at the board. This first 2 is the first shell. Second shell, it was contained first 5. After donation of the 3, remain 2 are here. So I already told 2 electrons form 1 bond. So how many electrons are 6? So 2 electrons form 1 bond. Here how many electrons? 6. So it will form 3 bonds. So that's why N, triple bond N. Done. Now this last shell contain how many electrons? 2. These electrons, that is 6 electrons, here 2, 2 and 2. These 6 electrons are known as bonded pair of electron or shared pair of electron. Why it is so called? Because these electrons shared between the 2 atom nitrogen. That is why they are called shared pair of electron. Among these 5 electrons, 3 only share, but remain 2 present in the outermost shell. So that is why it is called unshared pair of electron or lone pair. Do you understand? Since it is shared, that is shared pair of electron. It is unshared pair of electron or lone pair. Among these 5, 3 donated by 1 nitrogen, so 3 is shared pair, 2 is unshared pair. In this case also 3 is shared pair, 2 is unshared pair, that is lone pair. Do you understand? So tell me, now what is the total number of electronic configuration of each nitrogen? See, inner shell content 2, so 2, comma, outermost shell content 2 plus this 6, because this 6 is common, used by both this nitrogen and that nitrogen also. So 6 plus 2, 8. So tell me 2 and 8, it is the electronic configuration of which noble gas? Neon. So nitrogen form this 3 covalent bond by sharing the 3 electrons by each and gain the noble gas configuration 2, 8 like neon noble gas. Do you understand? So this is the full explanation about nitrogen. Now our third example. And the third example, it is completed. Now fourth example. Okay. Now fourth example is carbon tetrachloride. What is the formula? C, carbon C, and tetra means 4, chloride, that is CCl₄. Okay, now see, there are two different type of atom. In previous example, in part 5, first example is hydrogen H₂, same atom, see, hydrogen, both are H. Second example was chlorine, both are Cl. Now third example that I discussed in part 6, N2. So both these first two that discussed was in part 5. All these three contain same type of atom, but in this case different type of atom. Look at the board. First, carbon. So what is the electronic configuration of carbon? 6, so 2, 4. Now chlorine. What is the electronic configuration of chlorine? All of you know, 2, 8, 7, because it is 17. Now look at the board. We have 4 chlorine. Now each chlorine has tendency to accept 1 electron. Now look at the board. In case of carbon, outermost shell contains 4 electrons. So if it will accept extra 4, electron, so then it will get stability by Phillips octet, that is valence shell. So it will try to accept 4, and this also try to accept 1. So 4 chlorine, so each try to accept 1, so 4 atom try to accept 4. It also try to accept 4 because 4 chlorine are here, and it also try to accept 4. So if the both atom have the tendency to accept, then what they will do? I already discussed. They will form a common space. See, common space. Now 1 carbon and how many chlorine? 4. So this is 1 chlorine, this is another chlorine, this is also another chlorine, and this is also another chlorine, and center is carbon. Okay, now look at the board. First shell of carbon contain how many electrons? 2. So first shell contain 2 electrons. Done. Now tell me, second shell contain how many electrons? 4. So I already told second shell contain 4 electrons. So it will try to accept 4 to fill up its octet. So instead of accepting, it will donate 4 where? In common space. So this carbon, instead of accepting, why instead of accepting it will donate? Because I already told in previous part, if both the atom have the tendency to accept, then instead of accepting, they will donate in common space. So it will donate 4. So 1 here, another here, another here, and 4th is here. So carbon donates 4 in common space. Now each chlorine try to accept 1. So instead of accepting, it is also donate 1. So this chlorine donates 1. Another chlorine also same configuration. So now look at the board. This center chlorine towards the up direction, how many electrons? 1. So 1 pair electron. So 1 pair means 1 bond. Right hand side also 1 pair, lower 1 pair, and this is also 1 pair. Do you understand? So this is the structure of carbon tetrachloride. Actually, the structure of carbon tetrachloride is looking like this. It is called tetrahedral structure. Tetrahedral structure. Okay, but you can write this one for class 10 standard. It is okay. So this is done. So now can you tell me this carbon, after the formation of this type of covalent bond, why it is covalent? Because shared pair of electron. This type of covalent bond, carbon gets the noble gas configuration of which noble gas? See, previously 2, but after, see, look at this board here, carbon 2 electrons. Now 2 electrons, and this shared electron for all, anyone can use. So 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2 and 8. 2, 1, 2, 3, 4, 5, 6, 7, 8. So 2, 8 means neon. So carbon gets the nearest electronic configuration of neon. Now come here, chlorine. Chlorine, first shell contain 2, second shell contain 8. Okay, first shell contain 2, second shell contain how many electron? 8, and third shell contain 7 previously, but 1 donates here. So third shell contains 6. So here now in case of chlorine, 2, 8 is intact. Previously it was 7, but 1 donates here. So 6. So 6 and this 2, 8. So this is the 2, 8, 8 is the electronic configuration of argon. So after the formation of this type of covalent bond, carbon gets the electronic configuration like noble gas neon and chlorine argon. Done. Okay. Now our fifth example. All examples are important for your board examination in any of the section A or B. Now our fifth example is methane. See, in methane also two different type of atoms, carbon and hydrogen. So carbon means 2, 4 and hydrogen means also 1. Now tell me, this carbon try to accept how many electron? 4 to fill up its octet. This hydrogen try to accept how many electron? 1, because after accepting 1 it will form duplet. So it will try to accept 4. It will try to accept 1. But how many hydrogens? 4. So 1 hydrogen try to accept 1, 4 hydrogen try to accept 4. So it also try to accept, this is also try to accept. If the both atom will try to accept, then what they will do? They will form a common space. See, how many hydrogen? 4. So left, right, up, down. Okay, now in case of carbon, first shell contain 2. So draw first shell, 1, 2 electrons are here. So they will try to accept 4. So instead of accepting, it will donate here 1, 2, 3, 4. And hydrogen try to, each hydrogen try to accept 1. So instead of accepting, it will donate here another hydrogen, and another hydrogen. So look at the board. Carbon inner shell contain 2, but upside 1 pairs. 1 pair means 1 bond, right hand side 1 pair of electron, 1 left 1 down 1. In case of carbon tetrachloride, the actual structure of methane is same tetrahedral. But you can draw this one for class 10. So now look at the board. Here, after the formation of covalent bond, what is the electronic configuration of carbon? Previously it was 2, 4. Now 2 is intact. In covalent bond, only valence shell will participate. So 2 is intact, so carbon 2. Now this 4 pairs for all. So 1, 2, 3, 4, 5, 6, 7, 8. So 2, 8 again it behave like noble gas neon. Do you understand? Okay. Now come here, hydrogen. In hydrogen there is only electron 1, but it donates 1. So now hydrogen 2. So 2 means it behave like noble gas helium. Do you understand? So in methane, after the formation of covalent bond, carbon behave like neon noble gases, neon noble gas, and hydrogen behave like helium noble gas to gain stable electronic configuration like noble gas, nearest noble gas, helium and neon. Done? Okay. Now our sixth example. See, I cover all the concept. It is not this type of video, just I cover few important example based on the previous year. No, I'll try to cover all the concept for your ICSE board, all the concept. Okay, now our sixth example is water. See, here also two different type of atom, hydrogen means 1 and oxygen 2, 6. Okay, now look at the board. Hydrogen try to accept how many? 1. But how many hydrogens? 2. So each hydrogen try to accept 1, but as a whole it will accept 2. Now oxygen also try to accept 2. Why? Because after accepting 2, it has stable electronic configuration, that is complete octet. So now since both will try to accept, then what they will do? Common space. So oxygen, hydrogen, how many hydrogens? 2. 2. So now in case of oxygen, first shell, I already told, first shell not participate in covalent bond. So first shell 2. Now how many electrons are here? 6. So it will try to accept 2. So instead of accepting 2, it will donate to here 1, here another here. So previously it was 6. After donation 2, 4 electrons are remaining here. 4 electrons are remaining here. Now come to the hydrogen. Each hydrogen try to accept 1. So instead of accepting, it will donate 1. So this hydrogen donates here, this hydrogen also donates here. Now next step, oxygen. Right hand side how many pairs? 1. So 1 bond. Left hand side how many pairs? 1. So 1 bond. So now in case of oxygen, how many electrons are left in last shell? 2 to 4. So these electrons, I already told, these electrons are called shared pair of electron or electrons, but they are called unshared pair. This is shared portion used by both oxygen and hydrogen. That is why it is called shared, but it is unshared. So how many unshared pair of electron in last shell? 4. So 4 means 2 pair. So these are lone pair or unshared pair of electron over oxygen. So this is the structure of water. So if I will try to draw the original structure of water for class 10, it is okay. But the original structure of class 10, it will this structure will important for your class 11. If you will take science, then we have VSEPR theory, valence shell. This is called VSEPR theory, valence shell electron pair repulsion theory. From this theory we can predict the original structure of any molecule. So this is the structure of water, not the original. So according to this theory, what is the original structure of water? Original structure of water is like that same. Oxygen, how many hydrogen? 2. And how many lone pairs? 2. So 1 and 1. See, lone pair. You cannot understand why the shape of this lone pair is like that. Actually it is the P shell or P subshell. So it is not in our syllabus. So 2 lone pairs means 1 and 2. 2 pairs. So this is the original structure of 2, and its name also same like carbon tetrachloride and methane. This is also tetrahedral structure. Okay. Now, so this is the structure of water. Now tell me, after formation of this kind of bond, hydrogen atom here also hydrogen donates the electron and oxygen also donates the electron. Now tell me, after formation of this kind of bond, hydrogen form the electronic configuration of which noble gas? See, hydrogen outermost shell contain 2, so 2 means helium. So hydrogen form the electronic configuration of noble gas like helium. Now come to oxygen. Oxygen inner shell contain 2, outermost shell 1, 2, 3, 4, 5, 6, 7, 8. So 2, 8 means neon. So oxygen form the neon configuration like neon noble gas. Okay, now our last. Okay, now I want to share a very interesting concepts. I already told this is the structure of water. When you will dissolve some solute like sugar, after stirring you cannot see the particle of the sugar. Why? This is the water molecule. Suppose it is a container, water molecule. When you will add sugar molecule occupy in this cavity, that is hole of the lone pair. That is why sugar molecule is not visible. But if you will heat the solution, it is water, then after heating the kinetic energy of sugar molecule increases and it is then coming out from the cavity. Okay, water molecule evaporate and sugar molecule will come out from the cavity, then you can see the particle. But after stirring, since it occupy the cavity, so it is invisible. It is not in our syllabus, just for a fact. Okay, now our 7th example is ammonia. Our 7th example is ammonia. See, same, 2 different kind of elements. Nitrogen, so 2, 5, and hydrogen same 1. So now tell me, nitrogen try to accept how many electrons? 3. Hydrogen try to accept 1 to fill up its duplet. But how many hydrogen? 3. So as a whole, hydrogen try to accept 3 because we have 3 hydrogen. So it will also try to accept 3. It will also try to accept 3. So then what they will do? Same sharing 1, 2, and 3. Done. Now it is very important. Look at the board. Nitrogen inner shell, how many inner shell of the nitrogen contain how many electrons? 2. So done. Now nitrogen try to accept 3. So instead of accepting, it will donate 3. See, 1 here, another here, another here, and each hydrogen try to accept 1. So instead of accepting, it will also donate 1 here, another here, another here by nitrogen. Now tell me, nitrogen donates how many electrons? 3, because they will try to accept, it will try to accept 3. So instead of accepting, it will donate 3 here, 1 here, 1, another 1. So how many electrons are left from the last shell after donation of 3? 2. So look at the board, 1 and 2. This is very important. Why? I'll tell later. Look at the board first. Nitrogen in left hand side, how many pairs in common space? 1 pair, so 1 bond. Below, 1 pair, 1 bond. Right hand side, 1 bond. Now tell me, these 3, 1, 2, 3, these 3 pairs are known as shared pair or unshared pair? Shared pair of electron. But the electron present in the last shell that not participated in this shared pair bonding, that not participated in that type of bonding, is called unshared pair of electron or lone pair. How many pairs? 1 pair, that is 2 electron. So that's why in ammonia, on the nitrogen, 1 lone pair is present. So this is the structure of ammonia, and so original structure of ammonia is looking like the same, 3 hydrogen, and on the head 1 lone pair. Its name is also tetrahedral. So according to our syllabus, we have these 7 compounds, formation of the covalent compound. So I discuss all. This is there is no suggestion, and this is not a suggestive question. this is completely based on our ICSE syllabus. We have the total 7 compounds, that is covalent compound. So if you will prepare your note, your concept in this way, that is, if you cover all the topics that mentioned in your syllabus, then you will surely secure your 80 out of 80 marks. But if you will prepare in such a way that some suggestive video, some suggestion, question answer, yes, question answer is important, but first concept and theory. First prepare your all concept, prepare your all notes from your textbook in this way, then you can solve your question answer. But if you will see some suggestive video, suppose out of 7, if anyone discuss only 3 or 4, if this 3 or 4 type of question will come in exam, then you can solve this question. But if you prepare this all the 7, then if any one of this question will come, then you are able to solve this question. So first prepare your own note, watch this video, clear your concept, and then you are ready for question answer like previous year question answer. So for more question answer, you can join our WhatsApp channel, link given in description box. So thank you, and prepare all the parts. Next day I will come with part 6 of chapter 2, chemical bonding. Thank you.